everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about QoS, that is Quality of Service. What is the quality of service in network? That is we are going to discussing in today's session. First, let us see the overview. What is quality of service? First, we have to discuss that one. And next, we have to discuss what are the flow characteristics of that quality of service. Means whenever we are providing the quality to that particular network, what are the flow characteristics are there that we have to discuss. And next, we have to discuss what are the techniques to improve the quality of service. These all we are going to discussing in today's session. First, let us see what is quality of service. Quality of service means whenever the sender is sending some data to the receiver, this is the flow. We are sending the data. Whenever we are sending the data, how the data is going to be sent from the sender to the receiver, or how much the network is going to be reliable, how the bandwidth is going to be there, how the network is going to be means how much quality it is there. That is nothing but the quality of the service. Quality of the service is nothing but inter-networking issue, which is defined as a flow. What is the flow? Exactly flow. Means whenever we are sending the data, how the flow is going to be there in between sender and receiver. What is the condition of that particular network? How much quality it is giving this particular network? That is saying about the quality of that particular network. This is required for that communication. Whenever we are sending from sender to the receiver some data, that exactly we have to follow the how much flow, how the flow is going to be there. That is the quality of service. What are the flow characteristics are there? That is nothing but reliability. What are the main flow characteristics for providing the quality network? First, we have to check the reliability. And next, we have to check the delay also. And next, jitter and bandwidth. These are the flow characteristics of that particular network. Whenever we are saying that particular network is a quality network, then we should know about the reliability, delay, jitter, bandwidth of that particular network is nothing but the quality of the service. These are the characteristics. First, let us see what is reliability. Reliability is talking about. Reliability means from sender to the receiver, whenever we are sending the data, this particular network is reliable. Then only we can send the data. Means if the lack of reliability is, means the reliability of this particular network is less, then it will lose the packet. If the reliability is more, we can send the packet. Whatever data is sending from the sender, exactly receiver is received that data only. If the reliability is less, they may be losing the packets also. At the same time, losing the acknowledgement also, which results the retransmission of that particular data. If the packets are going to be loose, means we can send when we have to send again that data to the sender to the receiver. That is a lack of reliability. If there is less reliability, then we have to send the data again and again. That is the condition. If the reliability is more, we can whatever data is sending, exactly that data is received. That is the condition. And different application has the different reliability. Means whenever we are using different applications, wherever we are using different applications, we are going to focusing on the network quality. So different applications having the different reliability. Suppose if we go for the email, file transfer, internet access, then that time we need more reliability. Means we have to send the data. Exactly. That's why we need more reliability. And coming to less reliability, telephone communication, audio, video conferences, means there may be less reliability. Means telephone means only audio, means we have to we can focus on the less reliability. Thus, if the less reliability also, it will be acceptable if the telephonic communication. And coming to mail, file transferring, internet access, there may be chance of more reliability. This is the condition of the reliability for providing the good quality network. And the next one is the delay. What is delay? Delay means what exactly? What is the time? What is the time taken to transmit the packet from the source to destination is nothing but the delay. Delay means exactly time. At what time sender is sending, at what time receiver is receiving. Means time taken from the source to destination is nothing but the delay. So different applications tolerate the delay in different ways. How it is going to be different? Suppose if you go for the telephone communication, audio conferencing, video conferencing, remote login, they need minimum delay. Minimum delay, how it is exactly minimum delay? Delay means what? Time taking, how much time it is taking. So we should follow whenever we are going to audio video conferencing, the delay is minimum, because suppose if you start the video, means exactly the receiver is received that time only. If it is the receiver is received after 5 minutes, there may be delay. So that means minimum delay is required for video conferencing, audio conferencing. And coming to the more delay means, if more delay also, it will be suitable, like file transfer, email. We are sending the email, if you want to send the email, if it is receiving after 5 minutes also, it will be okay. There is no problem. If delay also, there is no problem. That's why here is more delay for file transferring and email messaging. That is about the delay. This is the next quality characteristics of the network. And next one is the jitter. What is jitter? Jitter is talking about the variation in packet delay. What is the variation? Means packet delay means time taken. What is the exactly packet delay means? What is the time taken from the sender to the receiver is nothing but the delay, packet delay. So in that time also some variations are there. That is nothing but this jitter. So suppose here I am sending the packets, 4 packets. That is P1, P2, P3, P4. So P1 is started at 0, P2 is started is 1, P3 is 2, P4 is 3. These are the starting time of the packets. So these are the departure time of that particular packets, and this whatever P1 is there, that is going to be arrived at that to receiver, that is at 20. P2 is received to 21, P3 after 22 seconds, P4 22 seconds. So like that if it is received. So here the delay is same, means if we count 20 minus 0 is 0, and 20 minus 0 is 20, 21 minus 1 is 20, 22 minus 2 is 20, here is 23, 23 minus 3 is 20, means here is same delay. Means however, whenever the packet departure time, if we calculate the departure time, arrival time minus departure time, the delay is same delay. Means if it is starting at 0 but received at 20, if it is starting at 1, it is received at 21, means the same delay it is following. This is one case. Suppose if all packets P1, P2, P3, P4, these all are started at 0, 1, 2, 3, but it is received to the receiver end. Suppose P1, P2, P3, P4. These are received at when it is received. Suppose if P1 is received 21, P2 is received 23, P3 is received 21, and P4 is received at 28. Means P1, what is the time here? This is the 21. This is what is the time here? 22. And what is the time here? This is 19. This is 25. Means here is the delay is different delay. So here is the different delay is going to be there in between the packets. That is nothing but this is the different delay. Suppose high jitter. When it is going to be high jitter means difference between delays that is large. If the delays, whatever difference is there, that may be large. If it is large is there, then that is nothing but high jitter. And low jitter. When it is calculated as a low jitter, difference between the delay, whatever delay is there, that is the same delay or small delay, then that is called as a low jitter. So always we have to go for the low jitter for quality of the for that particular network. And next one is the bandwidth. What is bandwidth? Bandwidth is talking about the number of bits. How many number of bits sent to that particular network? How many number of bits are sending to that particular network is nothing but the bandwidth. So this bandwidth is talking about different applications need the different bandwidth. Means bandwidth is saying that this is the sender, this is the receiver. How many number of bits are sending this particular sender? This is the bandwidth of this particular sender. So each and every different application has the different bandwidth. Suppose if we go for the video conferencing, the bandwidth is different. So this is having this needs the more high bandwidth because this is video conferencing. So it needs high bandwidth. Means whatever data is that should be we have to reach to the destination. That's why here is the high bandwidth. And coming to email, that needs the less bandwidth because after 5 minutes also we can receive the mail. There is no problem. So here is the less bandwidth is needed for sending that particular email. So this is also one of the flow characteristics of the quality of that particular network. These are the 4 characteristics. Those are reliability, delay, jitter and bandwidth. And next one is techniques to improve the particular quality of that particular network. That is the techniques to improve quality of service, quality of that particular network. So what are the techniques are there? First one is scheduling, and next one is the traffic shaping, and next resource reservation and admission control. These are the 4 techniques to improve the quality of that particular network. First one, in scheduling, again we have to divide it to FIFO queuing. That is the first one. Next, priority queuing. Next one is the weighted fair queuing. These are the 3 comes under the scheduling. And coming to traffic shaping, this is again divided to leaky bucket algorithm, and next one is the token bucket. Already in previous session we discussed about leaky bucket and token bucket algorithm in traffic shaping. That is nothing but the congestion control algorithms. Already we discussed this topic previously also. And next, resource reservation and admission control. These all techniques we can used for the improving the quality of the network. First, we have to see the scheduling. What is scheduling? Scheduling is nothing but packets from the different flows that arrive at the router for the processing. Means scheduling, how we are going to schedule when the packets are sending from the sender to the receiver, how we are sending that particular packets. What is the schedule for sending that particular packet is talking about the scheduling. Scheduling treats the different flows in pair appropriate manner. Means whatever packets are there, we have to send in that data into appropriate manner only. So first one is the FIFO queuing. FIFO means first in, first out. Whatever packets, so suppose this is the sender, number of packets are arrived to this particular network. Means who is coming first, that particular network only, that particular packet only use this particular network. Suppose this is 1, 2, 3. Suppose first is second one is reached first, means second packet is used first this network, and later if third packet is received to this particular router, means this will go to the after second one. And next, if if 3 is coming to this particular router, one is going to be used this particular network. That is the process. Means who is coming first, they will use this particular network. That is the first in, first out. The packet wait in a queue until the process is ready. Until the processes are going to be ready, packet, whatever packet is there, that is going to be waited in the queue. So to process them, if you have to process that particular data, you have to wait in the queue. If the average arrival rate is higher than the average processing rate, then the queue will be filled up and the new packets are going to be discarded. See how it is going to be. Suppose this is the scheduling. See here the packets are going to be arrival. Suppose this queue is going to be, suppose if it is queue, if the queue is full, the packets are going to be discarded. If the queue is not full, we have to store the data into that particular queue. All packets we have to store in this particular queue. So the processor are processing this particular data based on the arrival time. Means at what time the packet is going to be arrived, that based on that only the processor is going to be received that particular data. That is going to be departure time. That is the scheduling. Means first in, first out. Who is coming first, that will use that particular data. That particular network is nothing but the FIFO. Next one is the priority. Priority is nothing but priority queuing is talking about packets are assigned to priority class. Whatever packets are there, that packets all are assigned to that particular class, priority class. Means here we are going to use the highest priority and lowest priority. Each priority class has its own queue. So if it is going to highest priority, this is another one queue. If it is going to lowest priority, it is having the another queue. Means each priority class having their own queue. So the packets in high priority queue that can be processed first. Means who are there in the high priority queue, thus these particular queue packets are going to be first executed. First it will reach to the destination, that are going to be processed first, and whatever having the low priority, that packets are going to be processed at the last. Means whatever packets are there that in the high priority, that you have to process first. If all are completed, then only lowest priority is going to be processed. Means here it is there, the switch is going to be there. Here the switch is there. It is turned to the other queue when the current one is empty. Whenever the highest priority queue empty, then only it is going to be on. The lowest priority queue going to be on. After completion of this highest priority only, lowest priority queue is going to be on to processing that particular data. That is the priority queuing. Means based on the priority, high priority and low priority, based on that only we are sending the data. This is the priority queuing. And next one is the weighted prior queuing. Weighted prior queuing is nothing but this is the best scheduling method when compared to the FIFO scheduling. When compared to FIFO, first in, first out are priority, this is the best one because it follows the round robin fashion. Means whenever we are sending the data, that going to be process the data using, this is round robin fashion. Round robin fashion, we are going to send the data. Means for each and every packet we are allocating some time. After some time, it will move to the next one. That is the process. The packets are assigned to different classes and admitted to the different queues. These all are also admitted to the different queues. Weights are assigned to the queues. Whatever queues are there, we have to assign the weights to that particular queues based on their priority. Based on the priority only, we have to assign the weights. High priority has highest weight. Means who is having the highest priority to that particular queue, that will give to the highest weight also. High priority queue is having the highest weight also. That is the condition. System process packets each queue. In each and every queue, we have to process the packets in each queue, that is in round robin fashion, with number of packets selected from each queue based on the weight. Based on the weight, we have to select the packets. First, we have to process those packets, then only it is moving to the next one. If the system does not impose the priority on the classes, then all weights are going to be equal. Means if the queue does not have any priority in that particular case, then all weights are going to be equal only. That is the condition of the weighted fair queuing. This all comes under the scheduling. And next one is the traffic shaping. Traffic shaping already we discussed, right? There are leaky bucket and token bucket algorithm. Leaky bucket algorithm and token bucket algorithm. Leaky bucket means here the tap is there, here this is nothing but this is the queue. Whenever we are using this particular data, if we are filling this particular bucket, whatever data we are filling, that is the bursty flow. Whenever it is coming to the outside, that is the fixed flow, because the hole is fixed. This is already we discussed in previous sessions. Leaky bucket and token bucket in congestion control algorithms. Means the bursty flow is there, we have to regulate that data using the fixed flow. That is nothing but the leaky bucket algorithm. Means this is the bursty data. Means 0192. Here we are sending the data at the speed of 12 Mbps. At the time of 2 to 7, it is empty only. This is ideal only. We are not sending any data this particular time. Again from the 7 onwards, 7 to 10, we are sending the data at the speed of 2 Mbps. Means sometimes we are sending at high speed, sometimes medium speed, sometimes we are not sending any data. Means here different speeds we are using in these particular 0 to 10 seconds. So to regulate that bursty data, we are going to use the leaky bucket algorithm. Like whatever data is there, that is total 10 seconds, we are sending the data. How much we are sending the data totally? In 12 Mbps, we are sending the data within 2 seconds. Plus, this is the ideal time, means that is 0 only. And here the total is 3. 7 to 10, that is the 3. And we are sending at the speed is 2. See, total is 24 plus 0 plus 6. Total is 30. Means total data speed is 30 Mbps. We convert that data to these particular 10 seconds. If you want to regulate that particular data, so 10 into 3 means how much? That is 30. Means we have to allocate it. The speed is 3 Mbps for all these 0 to 10. That is the fixed rate of the data. That is the leaky bucket algorithm. And coming to token bucket algorithm. What is token bucket algorithm? Whatever tokens are there, whenever we want to send some particular data, we have to add the token. Whenever token is there, then only we can remove that particular data to the processor. We can give to the processor. So here first we have to check the queue if it is full or not. If it is full, we have to discard the packet. If it is empty, we have to add into the queue. After adding into the queue, this is the token bucket. For each and every tick, we have to, every tick is nothing but for every second it is generating the token. For every second it is generating the token. Means one token is going. If you want to use this particular packet, if you want to process this particular first packet, one token is going to be removed. That is going to be discarded. That is going to be processed. Means if you want to suppose here 3 packets means 3 packets are there, means 3 tokens are going to be needed to process that particular data. This is nothing but the token bucket algorithm. So here main concept is we are not going to be idle the any state. That is nothing but the difference between the leaky bucket and token bucket. There may be ideal states are there. So here the empty states are there. But coming to here, there is no empty state. That time it is collecting the tokens. For every tick, it is collecting the tokens. If the tokens is there only, then we can transfer the data. That is the token bucket algorithm. And next one is the resource reservation and the admission control. Resource reservation and the admission control. See here, resource reservation, flow of data. It is needs resources such as buffer, bandwidth, CPU time. So whenever we are transferring particular data, first you have to focus on the resources. What are the resources are there? Like what is the buffer condition, bandwidth, CPU time of that particular network. Before only we have to reserve all these resources. That is nothing but the resource reservation. Means QoS can be improved by reserving these resources. Before only we have to reserve these resources beforehand only. That is the resource reservation. And coming to admission control. Admission control is nothing but it is a mechanism mainly used by the router to accept or reject the flow based or predefined parameters. Suppose if you want to use this particular network, this is the network. Suppose sender wants to use this particular network, they have to follow some parameters, some rules. Then only they can access this particular network. Means before entering into this particular network only, that particular sender has to follow that particular network rules. That is the condition of admission control. to accept and reject this particular network. That is the condition. It has to follow predefined parameters. That is the admission control. Before accepting a flow for the processing, and router also check the flow specification to see the capacity of that particular network, bandwidth, buffer size, CPU speed, all it will check before that only. And previous commitments to other flows also it will check. That is the admission control. It has to check before only. Whenever it is going to be use this particular network, it has to check all the conditions. That is the admission control. This all about the improving the quality of service of that particular network. So, coming to the summary, in today's session we discuss first what is quality of service of the particular network, and next we discuss what are the flow characteristics are there, what are the flow characteristics like jitter is there, next bandwidth is there, reliability is there, bandwidth, reliability. These all are the different flow characteristics. Next one is the delay. These are all comes under the flow characteristics and techniques to improve the quality of the services. Like what are the techniques are they? Like techniques means what techniques? There is a resource reservation, traffic shaping. Traffic shaping is there. Admission control is there. Scheduling is there. All comes under the techniques to improve the quality of service to that particular network. All discussed in today's session. Thank you.